and the stream works. All right. Yeah, I won on Sunday. I won algorithmic engagements, which is the biggest individual Polish competition, and that's nice. I won it for a second time now. I don't think I'm the best Polish competitive programmer. I'm for sure in top 5, but it means that from time to time I will win such a competition by getting a little bit lucky. Today, I was looking now before a stream at problem F, the one I did a week ago, and I might understand what's wrong with that. So very quickly about it, if you watch the previous stream, then I think the issue is with something like that. I assume that if we do something not, in connected component order, then we can swap and the parity is the same. By the way, if you don't know that problem from a week ago, ignore it. We will move to the next one in a minute. But maybe there's something like this, like there is a tree, and like we do it in order, let's say this first, this goes first, and then this goes second, and this third. So that is forbidden by my algorithm, because we do 1 and then 2, and we can swap that. But actually swapping kind of connected components, maybe it will make things connected if we change the order. So if I say that there is connected component here, let's say, so I know that I'm quite vague here, but if there is here connected component C1, we do it and then we jump to C2 and only then they connect. Maybe if we do them in the other order, they are connected earlier, not at the same moment. Like consider this 1 and then 2, then 3. If we swap 1 with 2, 3, and we decide to do first this, then that, and then 3, we swap 1 with 2, 3, then this becomes connected. I'm not sure about that. This is very briefly what I think might be wrong with my program from a week ago. Anyway, we move on to E. What was the price? The sound is low, are you sure? I think it's very standard. The price was some kind of phone by Huawei. But today we are solving problem traffic lights, which is very hard. Nobody solved it during a contest. I asked somebody, like I don't know a solution, but I asked somebody if any hard theorem is needed. I asked a friend who knows the solution already to know if I will be able to at least comprehend the solution after looking at the editorial. And he said that it's fine. Just, it's hard to come up with it, but it's not that we need to know something crazy. Did you appear in Polish news? No. I mean, maybe some article online. Is the sound still too low? All right, let's get to know the problem. Free traffic lights, numbered 1 to 3. Traffic light I eternally repeats the following pattern: green for G seconds, red for R seconds. Actually, G1 and R1. All 3 lights have turned green just now. During the next blah, what is the total duration of the time when all lights are green? The limits are up to 10 to 12. We'll first try to solve it for up to 10 to 6th power. There is some kind of big cycle. Let's say that, or is there a small? Yeah, okay, we will work with this. For this input, the first light goes like that: green, red, green, red, green, red, and so on. The second one has cycled 2 green and then 1 red. Green, green, red, green, green, red, and so on. Then the third one is 3 green, then red. 3 green, then red. And now we're looking for some kind of big cycle there. This was the one. And we count moments when all three were green. I see these 3 moments. I messed up. How many moments did I count? How many there are? 6, 12. I see 12 here. Oh, yeah, there is also this one. But here I found a cycle using LCM. Of course, after LCM of green 1 plus red 1, which is cycle of the first light, then this, that. After that many turns, everything will repeat. And that's 12 for this case, because this is LCM of 2, 3, 4. But they ask us about situation after the product of that. We will need to at the end multiply the answer by product of the cycle sizes divided by LCM, some kind of GCD. We need you to hack the election again, comrade. I'm not Russian. I don't know what's happening. Will you do any other CSCS section as well? I don't know. As I answered in Discord, I'm good in geometry, so I did geometry, but it's not that I will cover all of them. Maybe some topic in the future. All right. 2 things I might try is ideas for subtasks. What happens if there are 2 lights, and also if constraints up to only 10 to 6th power. Those are 2 subtasks. Maybe. It's not that they said those are subtasks, but if problem is hard, you need to think about its easier versions. All right, 2 lights. When we look at 2 lights, if cycle sizes are coprime, then I would say that everything gets repeated, that everything is very regular. Let's say that one cycle size is of size 5, and maybe first 3 seconds are green, then 2 are red. But yeah, let's say this. And then the second one is just of size 3. And then here, I believe that every pair appears once. Like say 4, 2. Is 4, 2 here? Yes, it is here, 4 and 2. 4, 1 is here, 4, 3 is there. If 2 sizes, prime until LCM. Same should be true for 3 pairwise coprime cycle sizes. Lockouts or contests. Lockouts are fine from time to time. All right, now what happens if they are not coprime, right? Like if there's nothing more to do. Let's check. What are 2 non-coprime numbers that I can check? 4 and 6. Sounds reasonable. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 versus numbers from 1 to 6. What's going on here? 1 is only next to 1 and next to 3. Oh, and I didn't get a cycle. Didn't I? No, I did. And it's next to 5. So 1 is above everything that matches modulo GCD. So if we take GCD of size 1 and size 2, then X can be paired up only with numbers Y, such that X modulo G is equal to Y modulo G. I think. Then if we're given information, this is, okay, maybe this is bad name. This is GCD, or let's say uppercase B. I don't want to confuse it with green. This is what I analyzed here refers to cycle of size G plus R, where every second we have another color. There are a lot of colors. But if they're only green and red, then it's something like this. Let's say here first 3 are green, and here first 2 are green. 1 and 2. And we have here 2 situations with GG, and here 1 GG, and that's it. The answer is 3. How to compute it? We need to count pairs x, y such that this is true, and x is below green 1. Let's say that things are numbered from 0 to size -1, and y is up to G2. Wait, modulo G. Oh, what? Well, because normally we say x is from 0 up to size 1 -1. Y is from 0 to S2. No, yes, S2 -1. We want, among those numbers, count those with equal remainder modulo G and not exceeding some upper values, G1 and G2. You already know the solution, do I? Why do you think so? I mean, are you saying that this is the solution? Just checking my phone. Nothing urgent. Yes, LCM is least common multiple. If you're not sure about something like that, then this stream will be too hard for you. Sorry to say that. Right. Well, when I look at different remainders modulo G, then when I look at 0, let's take some example. S1 is 40, 50, S2 is 70, GCD is 10, and then when I look at remainders 0, then I know that x must be 0, 10, 20, 30, 40, and that's it. And y can be 0, this, up to 60. And now I want to satisfy those two. Let's say that G1 is 32, and G2 is here 42, and this is 27. Then I know where to cut. 32 and 70. I will say that x can be up to here, y can be up to there. This is remainder 0. All right, what about remainder 1 modulo G? Then every number, like x can be one of 1, 11, 21, 31, so on, y similarly. And the limits don't change. Still we have 4 possible x's, 2 possible y's, so 8 combinations. The number of available x's times y's is the number of pairs I get. And then something changes later on, like for number bigger than 32. When I consider 3 modulo G, then I will have 3, 13, and so on. and this time only up to here we should count x's. But this shouldn't be a big deal. Like for every small remainder up to this value, 32 modulo 10, including that, we have the same situation. Then we have one fewer, and then up to seven something happens, and bigger than 7 there is this smaller count of available y's. Sounds easy. So we can do this part in constant time, and it means that I solved the problem in constant time after computing GCD of two values. I think. Am I late? I mean, I recently started. You can read the statement. It's not that I solved the problem already. I'm still thinking. I'm actually thinking about easier version with only 2 traffic lights, not 3. And I will not answer a lot of unrelated questions. I will solve my hard problem, and that's mainly it. So I see some question about array in C++. I'm not touching that today. Maybe after I solve this problem, then we can do some quick ask. How is it called? Q&A. Yeah. Brute force. What is your question? Are you saying if I can come up with brute force for this problem? Yes, I can come up with one, but of course it will be too slow. We can have at most square root of this in complexity. I think I'm done with this. Hopefully I didn't make any mistake. But then we need to talk about free lights. 2 of them have some GCD. They create this pattern. Then 2 others have some GCD. Let's say that I investigated this, then I know pairs xy that are good. Actually, what does it mean that I have a pair x and y? What does it mean that I have 20 and 10? I guess I'm looking for some bigger value that is equal to 20 modulo 50, and it is equal to 10 modulo 70. Can I find such a value? So x equal to 20, y equal to 10. It is equivalent to, this represents a number, let's think, 10 modulo 70. That's 10 or 80 or 150. Or what's next? Plus 70, 220. I think it's 220. 220 is equal, this is like Chinese remainder theorem. This is equal to 10 modulo 70 and 20 modulo 50. I got the stream, nice. Well, I'm happy you joined, M-Wizard. But we have a hard stream today. Nobody solved this problem during a contest, even though the contest was longer than usual. So it's not a problem I will solve in 1 hour. My strategy is more about trying myself, and then once I'm done trying, just read the editorial and try to understand it. Cough? Yeah, I think still when you cough, probability that it's something bad is quite low. Especially when I don't hang out with many people nowadays. I try to stay at my apartment, not really meet with friends. nowadays. Yeah. I used to be more social. All right. Now when we have some other number, it will have GCD with 50 and with 70. And some of that can also have some non-trivial GCD with 10. Let's say that this third number is 14. And then it has, oh, I don't like it because it's just straight divisible by that. I chose two simple numbers. I wanted to take something divisible by 2, not by 5. No offense, I wasn't offended by you asking about me coughing. But still, let's investigate 14. It has GCD 2 with this number. Oh, sorry. And GCD 14 with this one. What does it really mean? When I look at this pair, this is pair modulo, this modulo 50, this modulo 70. Does it tell me if it will be divisible, and actually with what remainder it will be divisible by 14? I know what is happening modulo 2 and modulo 70 in this case, but this one can have its own something. Let's say that this is 16. Then from remainders modulo those, I know that it's even or that it's odd, but I still don't know what happens modulo 16. But this guarantees this guarantees green light for 2 lights. Then we have a third one. Yes, I use pen and paper all the time. Like here, what I'm typing there, normally during a contest I would do on paper. You can do so much on paper. This is, for example, how I analyzed the problem from a week ago. Of course, it's most convenient to do it on paper. Pen and paper gang all the way. It would be nice to say that when investigating those triples, so 220, then the next one, because we can add 350, not to mess up remainders modulo S1 and S2, which means that the next such number is 570. Then this plus 350 is 920, 1270, and so on. All those numbers, because of this pair, all those numbers have green light. I mean, two first lights are green. Then modulo 16. We'll have some kind of cycle there. Like we add plus 350. And this means this is coprime with 8 after dividing by 2. I believe we will have a cycle of 4. I think that this has some remainder modulo 16, and then this one has the same. Let's check it. Those 4 will be different. 220 modulo, Python will be better for that. modulo, let's say m is 16. This is 12. 10. And then it should be very regular. Oh, no, it's not after 4, after 8 steps, because something is messed up after 8 steps. We have 16, but all numbers are even. When we add 220 plus something modulo times 350, modulo m being 16, when we move to every next value, the remainder decreases by 2. It wraps around. Eventually, after 8 steps, it is the same as at the beginning. And now the question becomes, among remainders 0, 2, 4, and so on. In this case, we have remainders modulo 16 are 0, 2, 4, in some order, doesn't matter what order. How many of them are smaller than green 3? That's the question. Maybe I should think about it as, what's the probability that when I get random remainder modulo 16 among these, then I will have number smaller than green 3. If GI plus RI are pairwise relatively prime, then answer is G1. Yes, MWizard, that's right. No, not this. At the beginning, I figured out that I started from saying that for 2 numbers, then just every pair of remainders happens exactly once. The same is true. The same is true also for 3 numbers. If every pair is coprime, and then everything is very nice. Remainder 001 will appear once. 001, 002, 003, and so on. So yeah, then it's G1, G2, G3, the product. I don't know if all people who are very good at math think exactly like me. I guess it's similar, it's analyzing cases. Should this always be even? When we have this case, this odd case, then I believe that here we will have remainders modulo 16 are 1, 3, and so on, up to 15. Play button not working? You mean on Twitch that stream is dead? Can somebody confirm that? I don't see anything wrong on my end. What happens when we deal with some other values? We had this GCD of the first 2 numbers. Let's try again. Okay, let's try that just generally. We have S1, we have S2, and there is some GCD of them. We consider different remainders, modulo G, of the moment. And if we have, let's say, we want this, 3, then we'll have 3 comma, what was this? We increased by G. 3 plus g plus twice g, and so on. And same here. This is limited by green 1. This is limited by green 2. But in particular, 3 is here. Now we look at S3. We also consider S3. Modulo S3, we want it to be smaller than green 3. We already have this thing. Modulo size 3, we can be equal to 3. Then 3, we increase 3 by g. Okay, I think what matters here is GCD of g and S3. So what's the cycle? When we add g modulo S3, then what is happening? Let's call it g prime. Just double quotes to avoid this strange coloring. If something doesn't work on Twitch, then yeah, sorry, I don't see what to do about it. You can watch on YouTube at the same time. G prime is this. Let's call it what's similar to J, H. This is new GCD, and this GCD tells us something about the cycle modulo S3. What does it tell us? That I think this is the number of steps we'll take. For example, if S3 is 100 and G is 40, then by adding 40 like that, we'll make 5 steps. We'll have 3, 43, 83, and then after 163 we'll have 203, and that has the same remainder, modulo 100. Yeah, so 5 steps, because GCD of these two is 20 steps. All right, so we have a formula. Steps is 100 divided by 20, S3 by H. This is how many different remainders we have, and among them, among values 3 plus h, 3 plus twice h, and so on, count those limited by G3. Are those values modulo S3? Yes, I think they are. Is this a Chinese remainder theorem question? Yes, seems related. I cannot do anything about the buffering. I think that it's issue on Twitch's side, if YouTube works. My internet seems fine. I'm better with generating functions. I'm wizard. If it was a generating function, I wouldn't be able to solve the problem. But I don't think it will be like that, because as I said that at the beginning. But I asked friends about this problem, and they told me I'm able to solve it. I should be able to solve it. Because nobody solved it during a contest, I just thought that maybe it's a hardcore problem that I cannot comprehend, or that I don't know some requirements. They told me that, nah, I'm fine. Well, this h doesn't depend on the starting remainder, 3. So this seems too easy. Correct brute force would be to iterate over this starting remainder. Then I know values of G, I know values of H. Hi, new people in the chat. GRB, Panzetta, hi. If you all moved to YouTube because the stream is working better there, then fine by me. I don't mind. Let's try to write some code that transforms this into slow solution. I don't even care if it's linear or slower. I just want to make sure that I got everything right by now. Pseudocode is for every starting value, like this one, how to call a starting value A, from 0 to G minus 1. Can't remainder be bigger modulo this? Oh no, because H is only smaller. But is that fine for sure? All right. Count smaller than G1 in, so it's count 1 is count smaller than G1 in 3 plus G, and so on. Count smaller than G2 in this. That where H is defined here and the G is defined there. Well, let's try that. It won't be a long code. G1, R1. Should I use variables? Yeah, let's do it like that. G2, R2, G3, R3. S2 is equal. That S3 is the size of the last one, G3 plus R3. And now this. S1, S2. Later we'll use H, GCD of G and S3, GCD of all. And this I count as probability, right? I wanted to say here that answer is increased by the sum of counts. Not really. I think it's more like among this here we have modulo S3, some number of possible values. S3 divided by H will tell us how many values I have here. And among them, if I see that among 10 values, 3 of them are good, then 3 over 10 is probability of hitting such a number. All right. Should I do this with a for loop or with a formula? Let's go with formula. This is, smaller than G1. Say G1 minus 3 divided by G. Let's try this. If this is exactly 3, then this is 1. If this is 2, then it's 0. This is 3 plus G, then it's 2. But I want smaller than G1 because I start counting from 0. So if G1 is 3, then I want 0. That should count those values. Here, smaller than G1. Count 2 and count 3. As I said, we don't just multiply counts. Every count tells us kind of what's the percentage of good values. Like that. Count 1 among how many? S1? Print the ratio. I think ratio is the probability that we hit a good triple. As 3. Zero. That's not good. Ratio shouldn't be 0. Are these values computed correctly? G and H. 1 and 1. 2, 3, and 4. Sounds right. And then what do we have? G1 minus 1 minus A. I want at least one of these values not to be. Should I indeed take 3 here and not some kind of a modulo H? It shouldn't matter in this test. Let's print A, count 1, count 2, count 3. Count 1 is 0. Print 1 is 1. Let's think what is going on. Among numbers 0, I want to count those smaller than G1. And this is 0 divided by G, so something's wrong. G1 minus A. Let's look at this again. For a 3, I want to have values smaller than 3, so 0. Oh, but this is already 0. If G1 is exactly equal to A, then this is 0. Then I want, when it's 3, when this is 4 minus 3, then I want this to be 1 for the first time. Like this to round it up. Then if G1 is exactly equal to 3 plus G minus 1, then this is decreased, and for the first time we'll get 3 plus 1. No, when this is 3 plus 1. 3 plus 1 is the first possible G1 for which we should get answer 1. This is 3 plus 1 minus 3 plus this G. All right, now it's good. Then what should be here? H plus 1, H minus 1, or what? I think so. 0.25. This claims that among 24, every 4 value is good, so that is 6. 0.25 represents value 6, not 8. Damn it. Right, let's look at our analysis from before. Do I have something for this 2, 3, 4? I think I erased it, or maybe it was here. Yeah, this is the first sample test. What IDE? Genie. So we need to be 0 modulo 2. That's every second value. Then we need to be 1 or 2 modulo 3. So isn't my code just... I think that my code is fairly stupid. It just multiplies the probability that the remainder modulo first value is good, modulo second value, and third value. Well, I need something else. Modulo 2, and then we have modulo 3. Here, do we write down numbers up to S1? Yes, we do. G is 1. Why do I take G again? Maybe this should be LCM. Yes, this should be LCM. Where is my example from before? When I had 50 and 70, I wrote down values up to 50, up to that. So the starting one, okay, starting one was up to G. Chess programmers in the chat, I don't know what that is. Programming chess engines. Right. Sounds like machine learning and or heuristics min-max trees. Like to do so in the future. Just remember that chess is for sure very saturated. If you want to, I don't know, achieve something new, then for sure you need to go to another game, not chess. But maybe it's a good case to start from chess, because there will be a lot of materials on it. Neural networks. I don't know what state of the art. I mean, well, I don't know. I know something about AlphaGo. Maybe I would be able to also say what's used for chess. Anyway, why my logic doesn't work here? Why am I being stupid? For first two values, this is correct. Then we take the last one, and we say that GCD is 1. But this way I ignore the fact that third number isn't coprime with first or second. I just compare it with GCD. That might be bad. right? Let's think. We have this is not G. We don't jump by G. We jump up by this, by 10 being S1 divided by G. Right? No, this is GCD. So we do get something like x is 0 or 1, mod 2, then y is 0, 1, 2, mod 3. Then we are looking at values mod 4. And I ignore any kind of common divisibility of 4 and 2. And instead I just say that 4 is coprime with GCD of 2, 3, because G is 1 already. G was GCD of 2, 3, it's 1. Then I take GCD of 1 and 4, it's again 1. And I don't see any kind of pattern. And then I just try to say, yeah, among numbers 0, 1, 2, 3, 4, 3, I look for those smaller than green 3. And that's not good. AlphaGo devs have an amazing documentary on it. Yeah, I if you're talking about the 1 hour plus long video on YouTube, I have that in watch later, but actually I want to play some Go first, like on my own, and only then watch this documentary, because I'm not a big player. Maybe once I will. So like in 1 year I will learn the game, I will play it a lot, and then I will watch the documentary. Some values, yeah. Right, let's try to start fresh, because it was a bad idea to take GCD of the third number and GCD of first and second already computed as G. Rating to solve this problem. Nobody solved it during a contest, so let's say in code forces you need to be 3500. It's a hard problem. Let's try something else. If I can have linear time complexity, I can iterate over remainder modulo S1. And then maybe that allows me to handle the other two numbers in quickly, in constant time or off-log, just because I can deal with two lights very quickly. So if I iterate over remainder modulo S1, or let's say modulo S3, then I have some kind of requirement like I'm only interested in numbers 5, 105, 205, and so maybe 5 is about example because it's a divisor of 100. This will do the job. Among these values, because S3 was 10, and we are considering cases where this is true. So among all of those, if you choose random number out of these, what's the probability that we'll get proper remainder modulo S1 and S2? Right. I can compute 6 modulo each of them, and then I increase by 100. let's say now modulo 22, too big of a number, modulo 14, then that's 6, and then 106 is same as check modulo 14, that's 8. 6, 8, then it must be 10, 12, 0, 2, 4, 6, and we have a cycle. And modulo some other value, 9. No, I want something not coprime, not coprime, yeah. 8. 600 modulo 8 is 4. 2, 6, 2, 6, 2. In this case, we have a nice cycle of size 7. No, of size 14. Cycle, but that's 10, 12, 0, 2, 4, 6. Right? Yeah, we have 6, 6, and then at the end 6, 6. There is a cycle. And among this, I need to say what's the number of numbers here smaller than green 1 and there smaller than green 2. Yep. Yeah. This thing above was modulo 8, this thing is modulo 14. I can easily count here numbers smaller than green 1. And here smaller than green 2, but it's not the same. There might be some special correlation between them, I think. Unless we can say that it's quite independent and every pair will appear exactly once, then in constant time I can do this. Assuming that I can do it in constant time, then what? That was for 6. The sizes of those cycles don't change. I need to check every here remainder from 0 to green 1 minus 1. So instead of 6, this might be a different number. This might be a different number. Cycle size, so the length of this will not change. You probably did this already, but I casework bashed a formula for 2 lights. I mean, I don't think 2 lights is any kind of problem. I solved it in constant time after computing GCD. Maybe it's good to write down that formula, and maybe then it's useful to see it when thinking about this harder version. So 14 and 8. So when we look at 14 and also I can just implement this new idea and let's check if it works. Or let's actually simulate it by hand on the sample test. I have different remainders, modulo 4, the last size. If it's 0, then let's assume that this is true. Then modulo 2, we have 0 or 0 or 0, nothing. Then modulo 3, it is 0, or 0 plus 4, modulo 3, it's 1, and 2. And that's it. I say that here numbers, all those numbers are good, and here the first two are good. So 2/3 of good numbers. Then, if this is 1, then we have 1, 1, 1. That's bad. 0 good numbers. If it's 2, then it's just like this case. So, right, no, 2 is the first one. 2/3 of good numbers. And finally, this is bad. Because the last remainder needs to be smaller than 3. We have 2/3, 2/3, 0 and 0. The average of that will be 1/3. And that's correct. What would you get if input is this, 1, 1, 1, 1, 1? Well, I should get 1 because always all numbers will be 0 modulo 1. Oh, sorry, modulo 2. But do you have a reason to ask about that particular input, Daddy? If you think that like you thought about this case as something against my solution, then I can check it. Otherwise, you can simulate yourself. So let's try to implement this. For every remainder modulo the last thing, for every possible remainder modulo the last thing, green 3. We will compute some ratio and then do this. Because I want to compute probability, then when I choose triple, then it's good. So for every remainder modulo the last number, I compute this probability of good pair of the other two numbers and then take the average of probabilities. In the final code, we need to count this, but it's equally hard. I can as work with ratios. How many numbers among those are good? We start with, that's long. A is Z modulo, am I sure it's Z? Maybe green 3 is smaller than green 1. Maybe this should be the minimum of 3 values. I mean, S3 should be the minimum. This should be first. And then we keep adding S1. Maybe S3 should be... We keep adding S1. Among that, until we have a cycle, we need to count how many of them are good. Right, so how to do it? If we add like modulo 10, if we add 4, that's a cycle of 5. And the increase, maybe first the brute force. S1 plus S3, right? Because here I added 4 every time. I mean, here I added 100 every time. 100 being S3. Yes. Modulo S1. If this is the starting value, then break. And let's say here I consider this. If A is smaller than green 1, good plus plus, else bad plus plus. And then we need to do the same with the second value, so green 2 and S2. Or let's say this is a function. I don't want to think about a good name. This is its green and this is its S. What's wrong this time? Oh, yeah. New stuff that I wrote as comments. I should get 1/3. That's too much. Best money to earn money coding. I don't know, but I'm sure Google will help you. Competitive programming isn't. That's what I can tell you. Typo, but sorry, Hitchhiker, is there still a typo now? If yes, which line? Oh, this one. Thank you. It's the same. But thanks. So my previous code also shouldn't work. But in the sample test, it doesn't matter. All arrays are the same. It's all equal to 1. So thanks again for noticing. So we keep adding S3. Check if this is the initial value. What's A? Oh, yeah. That's closer, but not quite there. I think this is 3/8. Ratio 1 is this. For 0, it said 3/4. I got 2/3, right? Yeah, I got 2/3. And here it said half, and I got 0. Because those numbers are bad. What's going on here? For 1, I should get 0. Oh, this is 0, yeah. So the product is 0. Fine. Then just I need to fix this from 3/4 to 2/3. Let's investigate again why I got 2/3. Because when I have remainder 0 modulo 4, then modulo 2 for sure it's 0, and modulo 3 it's 0, 1, or 2. Is S2 computed correctly? Two, 3, and 4. All right. What's the good and bad? Let's compute new A. If it's repeated, then break. Otherwise, it's not repeated. So what, I should Google it? Or do you mean you should Google Erichto? Oh, I see the question. I'm from Poland. But there is my FAQ here. You can check a lot of stuff there. One, two, zero. Something is printed 3 times. Right. This shouldn't be global. It's inside a function. I shouldn't reuse it. And we have 1/3. Fine. Now something more important, because now reds will be different than 1. Four to 0 divided by 10 times 12. I'm multiplying sizes times 15. All right, this works. I assume that those two samples are enough to check stuff, though, well, it's not that strong. No, 2, 12, and 4 are not coprime, so this is a better test. We have a very slow quadratic solution. This part for sure can be improved a lot. I just need to investigate like GCD between step and myself, so between this and that, and something depending on this GCD will happen. I will have formula just like I used previously. Maybe let's indeed improve it. Step is what? GCD of that, like when I increase by 10 modulo 6, then every time it's equivalent to saying I increase by step. From 1 it would be 3, then 5, then again 1. And then the cycle size, if I need it, is s divided by step. If step is 2, then I have 3 steps. What do I do with that? Also, I have the starting value, and I need to, among these values, a plus step, and so on. I need to count those smaller than green. Smaller than green. Good plus plus. Divided by cycle size. What do they want from me? S is int? Shouldn't. I should have created like type def for long. All right, still the same answer, so I assume it's good. And now, yeah, this is some kind of formula. Count is, I had this similar formula before. G minus x divided by step. Let's think. If G is a plus 1, then it should be 1 for the first time. I mean, right? Yeah, this should say a. But if this is 1 in this case, I need to increase by step minus 1. And now this is constant time. Cool. Just speeding up a very simple for loop to count stuff. We have solution in complexity O of S3. So O of 10 to 12 power. Times GCD, whatever. But what are the similarities between different Z? There is A. A is used only here, right? Product of two ratios. It's not necessarily independent. But if green is quite constant, step is quite constant, then for consecutive values of Z, like they will change A by 1, and this should not change. If step is big, a lot of consecutive values is similar. Maybe the solution will be to do something if step is smaller than square root, and something else if bigger than square root. What is G? G is that. I will transform this a little bit. This minus A that many consecutive values of A, so that many consecutive values of Z are the same. And still, I'm not sure if S3 maybe should be biggest. Damn it. The stream is... Whoa, the stream is already 1 hour and 20 minutes. I sank so much time here. I wanted the stream to be only 90 minutes. Well, but I wasted a lot of time on some wrong approach. But still, I'm surprised how slow I am. Is this how we should do this? Save this just in case. And let's clean this up. Right. Narration always slows it down, so don't read the chat. I also doesn't reading the chat. Yes, but not that much. I spent in total 5 minutes talking with the chat. It was mostly going through tests here, looking at code. Maybe 10 minutes. We have two independent things. Like ratio 1 uses this, ratio 2 uses that. And we claim that a lot of values in a row will have same value. Step. S3. Do I use, where do I use S? Here. Step can, this can actually be computed like that once. It's divided by step. Alright, so this is also computed once. Those two use S and nothing else. So let's pre-compute that. Step 3. We know. Step 1. GCD of S1, S3. Cycle size 1 is S1 divided by that. Same for step 2. Now I will not get here S at all. I will just get step and cycle size. Still correct for the 2 samples. I'm not running the third sample because it has huge values. Yeah, that I will not run this in time. Maybe in 1 hour, but I don't want to wait that much. I moved GCD outside. Now I can focus that those 2 values exist. Those 2 values exist as well. And I have some simple division here, where A is Z modulo step. Step being here divisor of S1 and divisor of S2. Cycle size is then global. I always divide by it. So I can move it here or even there. It's more like, now I have code very similar to just computing cases, computing possibilities. Because I can straight like, get rid of this, say that I return long. Some ratio also it will be long. Add this and just don't divide by those. I will need to multiply by something, right? I mean, instead of, so I don't divide by that, but this is, I think I should multiply by step 1 and step 2. Cool. 420. It's no longer ratio. I will rename it as ways. Ways 2. All right. It's just GCD first third, GCD second third. Well, I simplified it nicely. What do we do? The numbers can in particular be coprime, but then this would be small. Let's think. I think that we'll need to do something like if one of those two steps is smaller than square root, step 1 is cycle size for these values. Step 2 is cycle size for the second kind of values. Minus a. Step minus that. We start with this divided by step. After a few iterations, we get this decreased by 1. And then after every step iterations, we increase it by 1 again. The change happens shortly after a is equal to g plus step minus 1 modulo step. When we have this, then it's like when this is true, then this count is, let's say, 5, and then when we have smaller by 1, then count becomes 4. Oh, wait, but because z is taken modulo step, oh, that's confusing. For the whole time now, I thought that this is z, the value from there. No, I didn't think so. That would be stupid. G plus step, that's completely constant. Minus 1, that's constant. So this can have only 2 different values? Because this ranges from 0 to step minus 1. Wow. That might be the crucial observation. But still, this is... Maybe I should write here z. Or a. Right, because this... Yeah, when we divide something by 10, and we can decrease it by at most 9, then division by 10 will change only by 1. Not more than that. If somebody is now joining the stream, by the way, we're solving this problem, 3 traffic lights. Link is like in the chat if you type !link. In YouTube, it's in the description. It's a very hard number theory problem. You can even pause the stream, read the statement. I have a linear solution, and I need to get something in likely of square root of that, or just log square. Or maybe this is smaller than 10 to 18 only because like some kind of multiplication would otherwise overflow, or so we could check if something is prime. But 10 to 12 usually means square root complexity. Square root of that will fit in 1 second. So modulo disjecity and modulo disjecity. Then this product can have only 2 different values. I think we got down to a problem with 2 lights, kind of. Adding step -1, g minus a. I don't want this to be negative. Green is smaller than step? It can be. Adding step is just adding 1 to this value. We mainly have just g minus something small. Which text editor? Genie. It's in top. You see here? Genie. We'll have a condition like this. Z is equal to some range. Let's say step 1 is 10. Then if G is maybe from 3 to 6, modulo 10, then ways 1 is 6, or just 13. Why not? Yeah, that's possible. And otherwise, ways 1 is 40. We'll have similar thing for step 2. Can step 1 and step 2 be independent? This is GCD of those two numbers, GCD of those. They can have something common, then they can not have something in common. Maybe if all three numbers have something in common, then I can divide all of them by it. Can think about it later. But let's say for now that step 2 is 15. I will have something like that. If Z is in range, it can wrap around 15. So let's say from 13 to 4, modulo 15. This means 13, 14, or 0, 1, 2, 3, 4. Then ways 2 is 80. Otherwise, ways 2 is 81. We need to sum up the product of ways 1 multiplied by ways 2 from Z equal to 0 to G3 minus 1. And this looks like an instance of the problem with two lights. Just in two lights we had some prefix. We needed to count, not really, we didn't have this range. So it's like a two lights problem, but only up to some moment. Can we solve two lights problem for upper limit for time? Say t. Or it's more like, can we? Let's try to solve this problem. This looks to me like some kind of extended Euclidean algorithm. I'm not sure. Also, I wanted to finish 6 minutes ago. I don't have enough time to solve this full problem. I'm not stuck, but from being curious, I think I will look just at the first line of the editorial to see if they go in this direction. Or should I not do it? Damn it. I would really want to finish this problem today. Now we'll have 2 unfinished problems. -70 -1 Twitch viewers, nice. Nice indeed. You can always create create multiple accounts and adjust the number, to always make it nice. But now I think it's 75. Yeah, sad. 6 viewers need to go away, or I can ban them. Yeah, 70 minus 1. I don't know what you're laughing about. You know what is also annoying related to 69? When, like, especially when you have lessons with young students, let's say you have a group of students in high school, and usually when you look at this, you say AI, right? Like, you can say A of I, like this is array of I, or just in short, maybe here you always say array of I, but in short you call this AI, like AI, AJ, and so on. Then how do you call this? This is BJ, and then also it will make some students laugh. Okay, this is 69 again. Nice. Proof. Here we go. Bans don't affect viewer numbers. Oh, I didn't know about that. When you're in Beijing, they sell t-shirts. I love BJ. That's quite ambiguous. Right. This problem. Does somebody here? I promise I did not laugh at B of J. Honest. Yeah. I just when working with young students, I just say B of J, so to like not make it funny in any way. All right. Does somebody here know a solution to this problem and can tell me if indeed we need to solve this as a subproblem? And I think that solving this 4 times, because we have here, like, when you deal with 2 intervals, you can add and subtract 4 prefixes for that. Like this would be asking about 0 through 2, 0 through 6, and subtracting that. And here 0, 13, 0, 3. And there's 4 combinations of that. I'm just here to see you struggle. Thank you. Very nice of you. When we had 2 lights, let's say with cycles 6 and 4, but we cut some time, what happens? Only we count cases here. We cannot anymore do what I did before. Would love to buy if you make competitive programming course. I don't think I will make anything paid for competitive programming. For coding interviews, yes, I will, but not for CP. All right, first line. Okay, M is cycle size. There is a tuple. Our task is to compute tuples like that. Sure. 3 distinct primes, sure. So, okay, they do something else. For some prime, if P divides M1 but not M2 and M3. Okay, I didn't have anything like that. So maybe Editorial says later something about 2 lights, but I don't know what they want to say, what is the fact. But yeah, I don't have this line. Maybe they want to say that we need to look at every prime separately and see which cycle sizes are divisible by it. If yes, then nope, I didn't do it. I just have this as a subproblem. Yeah, I need to finish stream in a few minutes. Sorry about that. So another unfinished problem. We have E and we have F. I cannot guarantee that I solve a problem in a single sitting. Nobody did it during a contest. And for now, by the way, I didn't use any editorial help. I came up with this myself. Except for this, I'm not sure about that. I hope that my solution is correct now, or at least after swapping some values around to make the last cycle size biggest. But I hope that this is solvable. Actually, let me quickly ask a friend. I mean, I just always ask in a group chat. Right? I asked my friends. I just expect a quick yes or no, because I'm sure that some of them know the solution. I just ask if we need to solve this subproblem constant number of times. The tutorial mentions that we can solve 2 lights 30 up to 10 to 12. Do we? So it's exactly this, and it says that we need to run this 4 times. If yes, then that's great. Then I moved towards the solution. And now if we deal with 2 lights, then for sure this is easier than the 3 lights problem. If this was huge, then anyway I would take it modulo the LCM of 2 cycle sizes. Okay, but that doesn't matter. It says we can generate all 2 lights change colors in... Oh, yeah. Maybe it's not that I necessarily wanted to be spoiled like that, but yeah, that's cool. I think that's the solution. When we have 2 lights, and let's say one have cycle size 10,000, the other one has 50,000, then when we look at the product of those, so like huge cycle of size C1 times C2, this one will... Oh, no, that's not true. This would be true if sizes were up to million, but maybe otherwise something good. Let's think. Yeah, I think we're good. There are t divided by S1 plus t divided by S2 switches of colors. Yeah, that solves the problem. If both these numbers are small, if both these numbers are big, then this is very small. If both are small, then we can just iterate over remainder of one of them. Right? Right, but Damn it, I need to finish. Right, my friend says that the intended solution doesn't use it. So we have some contradictions here. I'm mainly worried about how I got to this, so that I didn't. I hope that I didn't make any mistake in this part, in this code, and understanding it like that. If both are small, then what? Like this, and t is this. But then I can do that. And after it, if two are small, then t becomes small. So this is limited to s2 by s1. All right, easy. Now what's left is a case where s1 is small, s2 is big. Meaning this is around 10 to 6th. And this is around 10 to 12. And t is around 10 to 12. Can I solve this version? I mean, such a test. I cannot do any trick like that, but hopefully I can iterate over this. Oh, then still we have only few changes. S1 needs to be very small, like this. Because, well, we can have t divided by s1 in complexity, that would be fine. But if it's something like that, then remainders modulo that. I think when we look at values modulo s2, then it's something like this. There are a lot of green, a lot of red, and this length of this is 10 to 12. I can do jumps of length s1. Like this is of length s1, everything happens the same, this, that will be easy. I'm able to go once through s2 in constant time. Yeah, I'm confident that this solves the problem. I mean, solves the problem in O of s1, right? No, O of t divided by s2. So to sum it up, if at least one number is big, like this, I can do O of t divided by s2, or O of t divided by s1, or if both are small, then that's bad. But then eventually, if both are small, then like this will be whatever. I mean, what do I mean with that? Oh, or t modulo equal that, whatever, and then the former, this. Yep, that's solved. And this is squared. Right, that's some solution. It will not be long. I will not implement today, but I hope that this works. For any updates on this, I will let you know in comments below the YouTube video of this stream. Oh yeah, this is linked to YouTube, so you can watch all the past streams. And in comments below the newest stream, you can always suggest new stuff. I read all the comments. Join the Discord server if you want to hang out or give more suggestions. Sometimes vote on stuff I'm doing. And check out the schedule. All right, thank you all for watching. I am raiding no one unless on Code Forces Healthy UG is still streaming. Then I will raid him. Actually, oh, he's doing YouTube, not Twitch. Then I will not. But check out Code Forces live stream discussion. If you go to Code Forces, it's here. especially if you participate in code versus round. Right. Thank you everybody for watching. Bye bye. Stopping the stream doesn't work. I'm stuck forever.